Hello, my dear friends. Today I am going to explain the benzene and its derivatives. So, the structure of benzene. The structure of benzene has been of interest since its discovery. Benzene is a cyclic hydrocarbon, that is chemical formula C6H6. That is, each carbon atom in benzene is arranged in a six-membered ring and is bonded to only one hydrogen atom. According to molecular orbital theory, benzene rings involve the formation of three delocalized pi orbital spanning all six carbon atoms, while the valency bond theory describes two stable resonance structure of the benzene, that is structure 1 and structure 2. Both structure of benzene are same structure, but they are having this alteration of bond. These all structure are known as, that is, a resonance structure. So the structure with three double bond was proposed by Kekule as an attempt to explain how a molecule whose molecular formula was C6H6 could be built out of carbon, which make four bonds. The ring and the three double bonds fit the molecular formula, but the structure does not explain the chemical behavior of benzene at all. Oil. Each of the double bond would be expected to show the characteristics behavior of an alkene and undergo addition reaction. But this is not how benzene react. Why it is behave like as a alkene? Because we know that alkene it's contain carbon-carbon double bond. So in that benzene structure, they are having alternative double bond and single bond. So that carbon-carbon double bond is there. That's why it is known as alkene. Now, in particular, we would expect a carbon-carbon double bond to react quickly with bromine to make a dibromo compound. Like that is benzene when treated with bromine Br2, that is Br bond Br, it will give these two compound. Bromine dibromo benzene, both are same. This is what alkene do very readily, and in fact it is a useful test for alkenes in the laboratory. Benzene does not react with bromine unless a very bright light or a strong catalyst is used, and then the reaction is not an addition reaction. We conclude that there is something quite unusual about the double bond in benzene. Then Kekule, thinking about this problem before bond were understood as pair of electrons, suggested that there are two forms of benzene which differ in the location of the double bond. If you see that both structure A and structure B, so that carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5 and carbon number 6. Total number of carbon is 6. In case of structure B, there are also total number of carbon 6. But they are having only small changes or small differences is there. Only the double bond and single bond. Alteration of single bond and double bond. In case of structure 1, they are having carbon number 1 and carbon number 2, only single bond is there. But whereas in structure B, they are having carbon number 1 and carbon number 2, they are having the double bond. Now, his idea was that these were in a rapid equilibrium. So, rapid that there was never a fixed location for the double bond. One could say that approaching bromine molecule could not find a double bond to react with. the compounds. Thank you.